Živijo, pozdravljeni in pozdravljene v junijski epizodi podcasta Temna stran Lune, kjer govoriva o znanih in manj znanih straneh astronomije. Ker je to zadnja epizoda pred počitnicami, vam bova tokrat predstavili temo, ki se je lahko v prostem času lotite tudi sami in pri tem morda odkrijete celo kakšnega novega soseda v okolici našega Sonca.
Govorili bomo o občanski znanosti. V goste sva povabili Toma Bickloma, ki je eden izmed najbolj aktivnih članov projekta Backyard Worlds oziroma v slovenščini oddaljeni svetovi z domačega dvorišča. Razložil nama je, kakšne svetove išče, kako poteka njegovo delo in kaj ga pri tem navdušuje, pa tudi to, do kakšnih pomembnih odkritij so prišli s pomočjo občanske znanosti. Prisluhnimo intervjuju. In his spare time, Tom Bicklom, an astronomy student in Southampton, England, likes to blast heavy metal while combing through time lapses of the night sky, hunting for traces of a hypothesized ninth planet and other hidden objects lurking in the outskirts of our solar system.
Those were the words that the New York Times journalist used to announce a discovery that was made with a citizen science project that an astronomy student was part of. And this student was Tom Bicklom. So welcome, Tom, to the Dark Side of the Moon, our podcast where we shed light on the last known astronomy-related topics.
Thank you very much for having me. I'm very happy to be here.
So Tom, before telling us about this discovery, can you please tell us a bit about yourself?
Sure. So I am an astronomy student in the UK, an undergraduate, and a Backyard Worlds citizen scientist, which is Backyard Worlds being a citizen science project that I'm very much involved in and I'm going to talk about today.
So your journey into professional astronomy started with a citizen science project. So the citizen science project that you mentioned, that is Backyard Worlds Planet 9, is that correct?
That's correct, yes.
What inspired you to start your involvement in citizen science?
Well, I think I'd always had an interest in science, particularly space, but I never really pursued it after school or anything, so I could never go into it professionally as such. And in fact, I initially went to university to study German, which was
Wow.
I didn't particularly enjoy and didn't do that for very long. But effectively, one day I was just bored, and I was like, let me see if there's anything sciencey I can do on the internet. And the first thing that popped up was Zooniverse, which is this platform that holds lots of different citizen science projects. I immediately just went to the space section because they have all sorts of different topics. You don't just do astronomy ones. I think you can count penguins in Antarctica and transcribe ancient documents and stuff. But I went straight to the astronomy one and started doing it, and I love it. It's so much fun. And the great thing is that you don't need any experience, you don't need any qualifications. They make it very, very easy to do. So, yeah, that's really how I got started, and I'm still here. 6 years later, doing it.
Oh, wow. That's a dedication. So, can you tell us a bit more about the Backyard Worlds project? What is it about? What are the goals?
So, I'd say broadly, the goal is to discover new moving objects in the solar neighborhood. So that can come down to really two sort of branches. One is the outer solar system. So it's hypothesized that there is a ninth planet out several hundred AU astronomical units away from the sun, which is perturbing and sort of clustering some of the orbits of the really distant objects out in the solar system. And the theory is if that object is out there, it might be going, because it's so far out, it might be going slow enough that we can watch it going across the sky if we sort of put images one after another. of the sky over time, we might be able to spot it moving, much like Clyde Tombaugh did for Pluto. Most solar system objects tend to move a bit faster than Pluto because they're a lot closer in. But what we do with backyard worlds is use WISE, which is this infrared space telescope. But I should say was this infrared space telescope because it very sadly recently ended its mission and was allowed to re-enter the atmosphere and burn up, which we were very sad about.
Mm.
But we use images from WISE, which took an image of the entire sky every 6 months for a period of, I think it was best part of 15 years. So we have a lot of time series data, and we can look at images of the same part of the sky over 15 years to look for moving objects. And so we might be able to, if Planet 9 is out there, detect it with WISE. But what we're mostly finding in terms of new objects is brown dwarfs, which are a lot more difficult to spot with other things like optical telescopes because they're very, very faint. They sort of glow in the infrared. So we're finding a lot of them with WISE.
Yeah, you mentioned that we are finding, so also that there is there are many people involved, and how many people are actually involved in this project?
Well, participants wise, I think we've had over 175,000, which is kind of crazy when you think about it. Not so many. I don't think that's like all like really active participants, but that's like total. So that's mixed between people who've done one classification and then just moved on, and people who've been there since it started in 2017 and just stayed with it the entire time, being actively engaged in it. So that's quite good. But we have an advanced user group which has, I think, more than 300 at this point, which are citizen scientists who wanted to get more involved than just the sort of flip books that you do on Zooniverse. And they can come to weekly meetings, Zoom calls with the science team, the astronomers behind the project, just to get sort of updates on how the project's going. But the beautiful thing about Backyard Worlds is because we're discovering lots of new objects, a lot of these citizen scientists are able to then become co-authors on papers when we publish the discoveries. So 40 citizen scientists have actually been able to become co-authors on papers, which is very cool.
Yeah, I think that's wonderful. And also, well, you do the work, so it's only fair enough to be on the paper. Yeah, of course. So yeah, actually, I wanted to ask you a bit more about how does it work? Do you connect a lot with scientists abroad, and how is this collaboration working? So now you mentioned these weekly meetings, and you directly collaborate with professional astronomers. How does this work?
So yeah, the Zoom calls are really how we all come together into one group. But there's plenty of collaboration outside of that, and Slack is used a lot to communicate individually with people. So I've been working with a particular astronomer that we have in the group called Jonathan Gagne, who does work on a lot of young moving groups and roundels and stuff. So I've been doing that separately. We don't. I mean, we sometimes give updates in the Zoom calls, but that's we do that separately. So that happens all over the place with all sorts of, the citizen scientists working with the astronomers, some citizen scientists going and doing side projects with other citizen scientists. It's just a great sort of community function there.
Yeah, it sounds wonderful, especially, for example, members from general public who are not in science, but they always wanted to get involved. And this looks like a way how to get involved and work with professionals. It sounds very nice. But now I wonder, we didn't ask you. So what exactly do you do when you say you do citizen science and you are searching for these objects? How does this look like, a typical day of a citizen scientist?
So for Backyard Worlds particularly, you can go to backyardworlds.org and it will take you to the Zooniverse page for Backyard Worlds. And what it's showing you is image after image after image of a random patch of the sky using WISE. and you're looking for anything that moves. So we put it in difference imaging, which basically means that we're only showing things that change. So anything that looks the same won't show up. So anything that's moving will obviously stand out more clearly. So what you have to do is click on the object and then click done, and that's really it. There is another thing you can do if you want to get your object to the science team quicker, which is that they have a form called the Think You've Got One form, where you can put the coordinates in and your name, and if you put the email in there, then the team can more easily reach out to you to maybe invite you to the advanced user group.
Okay, so it sounds pretty easy. You check images, you click buttons, and that's it. So do you need any knowledge, or can just anybody can come and do it?
Anybody, absolutely anybody. The projects tend to be quite good at, if there is a certain amount of knowledge involved that to be able to do it, they do little tutorials that you can do before sort of, and it's done in sort of layman's terms, so it's quite easy to understand. You don't need a scientific background, and particularly when it comes to brown dwarfs and stuff. Most of the general public probably have never heard of a brown dwarf, let alone studied them. So it's quite convenient just to be able to sort of do it without the knowledge.
How many objects did you check and analyze so far?
In fact, I looked this up today. I can't tell how many I've submitted. I've probably submitted thousands, but the number of candidates that we've retained as brown dwarf candidates is something. It's almost 900. Personally, I think we have a total of several thousand candidates, but personally, almost 900. And I say candidates because we haven't got spectra of all these objects, so we can't technically say they're a brown dwarf with certainty, but they're red, faint, and moving, so there's not a whole lot else they could be.
And another related question is, why do you have to do it by eye and there is not a program or a machine doing it, right?
Yes. So there certainly have been attempts made, and it's certainly, machine learning is very much a sort of growing field. But what we found is that really there's no substitute for the human eye when it comes to detecting this motion. And it doubtless at some point there will come a time where computers and machine learning just obliterate us at finding these things. But for the moment, we're enjoying being slightly beating machines, I think.
If I remember also I remember that the first project that I was hearing about was the Zooniverse, that is now a platform that is collecting all these citizen science projects, right? And Zooniverse was also a project with human eye, just trying to catch which kind of galaxies are on some survey, right? Have you ever played with that also?
So I think that was the first universe project called Galaxy Zoo. I have done some of that. You basically they show you a picture of a galaxy, and you sort of say, is it a spiral galaxy or elliptical? Is there anything interesting about it? Has it got a nice bright core? Things like that. So that's quite easy to do as well. I have done some of that, but I must admit I've sort of fallen in love with brown dwarfs, so most of my time goes to backyard worlds.
Yeah. So as you mentioned, citizen science is still, despite all the artificial intelligence and everything, humans can still do it much better. So can you tell us something motivational? For example, why should somebody, especially young people, why should they get involved in such a citizen science project? And how does such a project differ from a typical or ordinary science project?
So I think there's lots of reasons to get involved with citizen science. Firstly, sort of access to doing science in a professional setting, right? This is professional scientists having lots of data. We live in a world of big data. There are lots of sort of astronomical catalogs that have billions and billions of sources. It's just not the manpower required is beyond the capabilities of the professionals. So access to the sort of almost doing the professional science yourself almost is quite appealing, I think. But also discovery. Who wouldn't want to discover new things? I mean, it's very cool. And as I say, I mean, for some projects, if you discover things, you can be a co-author on any papers that come out, which is also very cool.
Yeah, it sounds wonderful. Actually, we haven't really asked you, but well, you haven't told us. You said that yes, you can, as a citizen scientist, you can get involved and co-author papers. And yeah, this is also your story, right? This is how you got involved, and today you are studying astronomy, right?
Yes, so it's very much down to Backyard Wells that I'm doing this degree in astronomy. I mean, I just sort of did it for fun. As I say, one day I was bored, and I caught the sort of brown dwarf fever, I suppose. Got very, very interested, absorbed as much of the literature as I could, and before long I sort of transferred from these days. I transferred from less discovery and more characterization now of objects, which is kind of cool because that's not a typical sort of. You don't get a lot of citizen scientists or members of the public doing the characterization of the objects. They're mostly doing the discovery.
Yeah.
And eventually I just thought, yeah, I want to do this professionally. And the only way of doing that is go and get your degree and go from there. So I did it.
Yeah,
I'm
I
in the
find
final
this.
year now.
Yeah, wow. I find your story is super, super inspiring. And yeah, I hope that your story inspires somebody else as well.
Mhm.
Hopefully,
So can you
I mean,
explain? Sorry.
so hopefully, it's this is why I love. In fact, I gave the talk at Core Stars where we met. I gave the talk on citizen science. I love citizen science, and if doing the talk and coming on podcasts like yours is able to get more people to get involved and sort of go through the experience I had and of discovery and sort of life-changing stuff, then that can only be a good thing.
It really is life changing. Yes.
Yeah, just for the listeners, we have to explain that there is a conflict of interest in the sense that Marusha and Tom met at a conference called Cool Stars, right?
Yes.
That's right, we did.
Well, actually, yes. I think I should tell this story. How we met. First, I listened to Tom's talk about backyard worlds and all these cool discoveries, citizen science. But it was the first time I've seen him, and then after a few days, I forgot who this person was who gave a talk. And then there was a conference dinner, and somehow we started to speak. And I was telling him, "Oh, there was such a cool talk about citizen science, and this person got involved in the papers and got to study astronomy. This is so cool." And then Tom said, "Oh, that's me." Yeah, that's something I'll never forget. This is how we met.
So, Tom, can you explain a bit what kind of discoveries have you made with backyard worlds? I believe that those are not only discoveries, as you said, not only discoveries of new brown dwarfs, but also some other stuff, like you mentioned, characterization of those objects. So, what is the cool things that is going on that subject?
Yes. So the bulk of our discoveries are brown dwarf related. Should probably briefly explain what a brown dwarf is. Which so brown dwarfs are objects that they form like stars. You get a big molecular cloud that sort of collapses under its own gravity, forms. Well, a star has enough mass that eventually it gets nuclear fusion occurring in its core, hydrogen fusion, and so it sort of generates its own energy, whereas for a brown dwarf, it forms like a star, so it's still the collapse of the molecular cloud, but it doesn't get enough mass to start the hydrogen fusion in the core. So it has the heat from its sort of formation, but it doesn't generate its own heat after that. So it sort of just gradually cools off over time. And so there are you might have heard of, so the listeners might have heard of the OBAGFKM stellar sequence of spectral types. For brown dwarfs, we sort of continue that. From after M, we get L, T, and Y. So brown dwarfs, the L dwarfs, sort of cloudy, and then T dwarfs, the clouds have sunk below the photosphere, so we don't really tend to see the clouds at that point. And then the Y dwarfs are the coolest type of object. We don't know of many of them, but they are more similar to planets like Jupiter, big giant gas planets. And in terms of discoveries, well, I suppose we could start. We could start with the what we mentioned in the intro, which was the really fast hypervelocity object that was in the New York Times. So that was a low metallicity. So in astronomy, we talk about metals. We're talking about anything that's heavier, any element that's heavier than helium. So a low metallicity, we don't have many elements in there that are heavier than helium. L subdwarf. So subdwarf is really the word we use for a low metallicity object, and it's going so fast that it's possible that it's going so fast that it might escape the galaxy. It's very, very fast. And so that was picked up. In fact, when I saw because we work in kilometers per second generally, for brown dwarf velocities, and in the article they sort of converted it to miles per hour. So when I saw 450 kilometers a second, I thought, oh, that's fast. And then when they said 1.2 million miles per hour in the article, that's when it sort of clicked for me. I was like, whoa, that is fast. So that was, I think that's probably why I got so much press. It's that big million miles per hour number. But we have found other type of low metallicity objects. There's one that we called the accident, because it was discovered accidentally. And we think it might be the first Y-type subdwarf. So we're looking at an extremely low metallicity Y-type object, which is very, very cool. That would be the first one we've ever found. On top of that, we've found lots of companions to nearby stars. So over 100 brown dwarfs that are sort of orbiting other stars. We tend to find them on the wider orbits, because when they're close in, we can't really resolve them with Ys. They're sort of blended in the light. But when I think the best way of talking about Becker was discoveries is to sort of quantify it. And there was a 20 parsec sample done recently, 20 parsec distance around the sun. We got all the objects within 20 parsecs. This includes stars, brown dwarfs, other things. And it turns out that 3% of all the objects within 20 parsecs that we know of were discovered through backyard worlds, which is kind of crazy for a sort of project that's been going for 7-8 years. 3% of all the objects in 20 parsecs is crazy.
Wow.
If you limit that to just the L, T, and Y dwarfs, so just brown dwarfs broadly, it's 19%. So basically 1 in 5 brown dwarfs within 20 parsecs was found by our project in the last 7 or 8 years. Now, the good thing as well is that we've got a 2021 paper which did a census of brown dwarfs within 20 parsecs, and a 2024 paper which did a census of brown dwarfs and everything else. So we can compare in those 3 years how many brown dwarfs were added, which is, we discovered 65 new brown dwarfs within 20 parsecs in those 3 years. 58% of which were discovered through backyard worlds,
Wow.
which means that we are now the main source of new brown dwarfs within the vicinity of the sun, which I think is very cool.
And so in this sense, since you are working on data that were collected by a telescope that is not here anymore with us, so is it pointing toward another telescope of the same kind, maybe, to collect more of that data?
It's a good question. I'm not aware of another. I'm not aware of another one that's going to do like the same sort of extent of time series data. I think. Oh, I forget the names. I mean, Euclid is up there taking near infrared images, but also spectra, which is really nice. So we can get some nice brown dwarf spectra, and there have been some early release papers with brown dwarf spectra. So that's where we're already making discoveries. If there are new, surveys doing imaging, I certainly not for a while. We wouldn't be able to do anything like the scale we're doing with backyard worlds because we have 15 years of data of the entire sky.
Yeah.
Uh,
Yeah.
so, I mean, we could try combining it, but it's going to be they're different wavelengths, and I don't think there's anything looking at the same wavelengths because this is sort of near to mid infrared for WISE. It went out to I forget, it was like 24 microns or something. No, was it 24? Something like that. Something like 24 microns, which you don't. I don't think there's anything up there looking that deep into the infrared.
Yeah. It needs to be in space, I think.
Yes. Yeah.
So for the listeners, why the Hubble Space Telescope is not enough to collect those data?
So Hubble's great, but there's multiple reasons we can't use Hubble. The main one being that you have to write a proposal, and your proposal has to be in the top whatever 10% or 5% or whatever to get time, and then you're never gonna get. There's only a limited number of hours available, and to get the whole sky, it's way too many hours. But also, Hubble is optical. It looks in the optical. Kind of, it could look in the near infrared, but I don't think that it would be anywhere near as good at detecting the sort of colder objects, which tend to peak way later in the infrared than Hubble can see.
Yeah. But these numbers that you mentioned, it seems that we still don't know our neighborhood. How many objects were discovered just in the past few years? So many new, and then there must be many more.
There must be, no question. I mean,
Mhm.
I'm trying to think of how close the accident was because we discovered that I think 5 years ago, and I think it's definitely sub. It's definitely within 20 parsecs. There's so many objects being added within 20 parsecs, and that's sort of formally considered our solar neighborhood as such.
Mhm.
But also when you consider that, it's quite a new field, brown dwarfs. I think
Yeah.
the first one was found mid 90s.
Mhm.
So whereas like all the stars, we've had decades or centuries to look to look for nearby stars, but brown dwarfs, we've only recently had the sort of telescopic data to be able to find them, which is certainly in bulk. Like WISE was unprecedented for that, and yeah, greatly miss WISE.
Yeah, so I think that's a very good motivation for people who are thinking of starting citizen science. Yeah, there are objects lurking in our neighborhoods very close to us, and we still don't know them. So, yeah.
Absolutely, you can find the nearest object to the sun.
Yes, actually, yes. That's a very good motivation.
And the final question: are you sure you will find Planet 9?
We're, we're not even sure it exists, to be honest. It's I mean the science involved to work out the orbits of the trans-Neptunian objects and all that stuff. I haven't really looked into it, but there does seem to be quite a lot of debate as to whether it even exists. So we haven't found it yet, which might well be evidence that it's not there, but hey, it could be. And if it's there, wise could well be the best instrument to find it. So it's worth looking.
Yeah, yeah. One more question. So you mentioned the accident a few times now. Why such name?
So one of the citizen scientists in our group called Dan Castleton, he's made this sort of machine learning thing to look for new brown dwarfs. It's funny, we were talking about machine learning earlier,
Mhm.
and it's making some nice discoveries. And he was just going through some of the coordinates that his algorithm had sort of picked out, and he put the coordinates into a program he created called WiseView, which basically shows you a time lapse of the WISE images.
Mhm.
And not at the coordinates it had said, but in the corner of the screen, he just spotted this like really fast moving thing. So completely accidentally found this thing, and it just happens to be the weirdest brown dwarf we've ever seen. It's the whole story is wild. But yeah,
Wow.
that's the reason behind the accident, because it was accidentally discovered.
Wow, so cool. And he was so lucky.
We were quite pleased that we managed to get the accident into a paper without, either the referee or the journal being like, maybe not, don't know.
Yeah, yeah. Very cool. Literally.
So, Tom, thank you for sharing your interesting story. Yeah, I believe that the concept of citizen scientist is maybe much clearer to our listeners than it was at the beginning of our interview. And maybe some of them will also join some of the citizen science projects that are on astronomy or other topics that are available online. And yeah, we hope also that you will make many, many more discoveries of some strange and particular objects in the sky. Thank you very much for being with us.
Thank you very much for having me.
Tudi v Sloveniji je nastala in se počasi tudi veča mreža občanske znanosti. Spletna stran, ki je namenjena, je citizenscience.si, jo bova dodali v zapiske. In ta mreža občanske znanosti združuje različne organizacije in posameznike, ki izvajajo projekte občanske znanosti, organizirajo različne dogodke in tudi predavanja. Mrežo koordinira Centralna tehniška knjižnica v Ljubljani in njen član je tudi zavod Kozmolab, pri katerem sodelujeva skupaj z Marušo. Mreža občanske znanosti organizira letos poleti razstavo na Krakovskem nasipu v Ljubljani, kjer bodo predstavljeni nekateri projekti občanske znanosti, ki so potekali ali še potekajo v Sloveniji. Pri zavodu Kozmolab pa se pripravljamo na skupno sodelovanje, kjer bomo za pomoč pri izvedbi prosili občanske znanstvenike in znanstvenice, da se nam pridružijo. Več o tem vam bova razkrili v naslednji sezoni, oziroma, če želite izvedeti kaj več, bodite pripravljeni in sledite tudi spletni strani kozmolab.si. Kaj vse bomo lahko opazovali poleti na nočnem nebu? Seveda, ker je poletje, ne moremo mimo tega, da omenimo perzeide. Perzeidi so meteorski roj, ki ga običajno opazujemo sredi avgusta, in verjamem, da ste poslušalci in poslušalke že marsikdaj opazovali ta roj. Letošnja opazovanja pa bo motila luna, saj bo polna luna nastopila nekaj dni pred maksimumom tega meteorskega roja. Torej, vrh aktivnosti bo letos med 12. in 13. avgustom, vendar zaradi omenjene svetle lune bo možno videti le najsvetlejše meteorje. V letošnjem poletju bo iz vidika opazovanj in mogoče takih posebnih dogodkov, kjer se luna sreča z nekaterimi planeti, večina zanimivosti potekala tik pred zoro ali pa kmalu po sončevem zaidu. Večino teh najdete recimo opisanih v knjigi Glej jih zvezde, v kateri so opisani torej taki prizori, ki jih lahko s prostimi očmi ali pa enostavno opremo tudi opazujete čez vse leto, v resnici ne samo poleti. Ampak kot omenjeno, v poletnih mesecih pač se bodo planeti počasi premaknili v različne lege, torej Merkur, trenutno viden ob mraku na zahodu, bo avgusta viden ob zori na vzhodu, Venera, ki je vidna ob zori, bo avgusta vidna v drugem delu noči, Mars, ki je trenutno viden v prvem delu noči, bo avgusta viden v mraku, nizko nad zahodnim obzorjem, Jupiter bo avgusta viden v drugem delu noči, Saturn pa, ki je sedaj viden v drugem delu noči, bo avgusta v resnici viden čez celo noč. In med omenjenimi prizori bi mogoče opozorila na to, da bo 29. junija bosta Lunin krajec in Mars dovolj blizu na nočnem nebu in to 2 uri po Sončevem zaidu. Še en tak pomemben dogodek, ki se bo zgodil, bo popolni lunin mrk 7. septembra, ki ga bomo opazovali takrat, ko bo luna vzhajala in vzhod bo kmalu po 19:30 oziroma malce prej bo začela vzhajati luna, takrat bo nastopila med drugim tudi polna faza, kar pomeni, da bomo v bistvu opazovali drugi del luninega mrka, ko bo počasi lezla luna gor nad zahodnim nebom in mrk se bo zaključil nekje po 22. uri. Pa še en tak dogodek mogoče, oziroma prizor, ki bi lahko bil zanimiv, se bo zgodil od 8. na 9. september. Takrat bomo pa lahko videli Saturn v bližini lune, ki bo skoraj polna in to na vzhodnem nebu ob koncu mraka. Skratka, več takih dogodkov se bo dogajalo v poletnih mesecih. Seveda vabljeni, da preizkusite tudi sami katero izmed aplikacij, ki jih običajno tudi omenjava v podcastu in ki vam lahko služijo za razpoznavanje torej ozvezdij in svetlejših teles na nebu. Spletne povezave bova dodali torej v zapiske kot običajno in lahko najdete tudi med zapiski spletne povezave za spremljanje preletov mednarodne vesoljske postaje in vesoljskega vremena ter sončeve aktivnosti nasploh. Skratka, upava, da bo vaše poletno opazovanje nočnega neba uspešno.
To je bila zadnja epizoda 5. sezone podcasta Temna stran lune. Čez poletje odhajava na počitnice, ponovno pa se slišimo jeseni. Predloge, pohvale in kritike sprejmeva na podcast.temnastranlune@gmail.com ali pa na družbenih omrežjih, kjer naj najdete z uporabniškim imenom Temna stran lune.
Zahvaljujeva se tudi vsem, ki s svojimi prispevki podpirate ta podcast. Najino delo lahko podprete tudi ostali, in sicer simbolično kavo, ki nama jo lahko ponudite na spletni strani ko-fi.com/temna stran lune. Najdete jo v zapiskih epizode.
Podcast je del mreže aktivnosti Zavoda Kozmolab, ki se ukvarja s promocijo in popularizacijo astrofizike. Na spletni strani kozmolab.si najdete povezave do portala v vesolje in portalovega podcasta, kjer kozmolabovec Jure Japelj objavlja zanimive novice o vesolju in astronomiji.
Za glasbeni uvod in zaključek epizode se zahvaljujeva Peliju iz sosednjega podcasta Opravičujemo se za vse nevšečnosti. To je podcast o življenju, vesolju in sploh vsem, ki ga soustvarjajo Peli, Aljo in Zi.
Hvala, da ste bili z nama v tej že 5. sezoni podcasta. O novih epizodah že razmišljava in jih tudi načrtujeva, zato nama ponovno prisluhnete jeseni.
Z vami sva bili Dunja
In Maruša.
in se slišimo čim prej.
Lepe počitnice.